everyone, we're going to identify and graph the polar equation r equals 2 minus 3 cosine of theta. This is going to be a Limacon with an inner loop. I will show you why momentarily, but first let's check for symmetry for our graph. So basically we want to check to see if our graph is going to be symmetric to the polar axis or the x-axis. So you take your r and substitute in, for theta, substitute in negative theta. Since cosine is an even function, that can be changed to positive, so our equations are equivalent. That means it passes the test, and our graph is symmetric with respect to the polar axis. Now let's check the second test to see if it's symmetric to the line theta equals pi divided by 2. That means we're going to replace theta with pi minus theta. So we're going to take r equals 2 minus 3 cosine. Instead of theta, you're going to write pi minus theta. Now this is from your sum and difference formulas. It has this form. So let's expand it. And that's going to give me equals 2 minus 3 times cosine of pi, cosine of theta, plus sine of pi times sine of theta. Sine of pi is 0. That goes away. So that's just 0. This is negative 1. So you have your two negatives are going to make a positive. You're going to get 2 plus 3 cosine of theta, which does not equal 2 minus 3 cosine of theta. So this second test here fails. It's not going to be symmetric to the y-axis here. All right, let's check the pole. So for the pole, the origin actually, all you're doing is substituting your r for negative r. It fails because we don't get back the original equation. The only time this one's going to pass is if you have a r squared. So we don't have a r squared. So this fails. Now let's look and see why this is a Limacon with the inner loop. It has the form where this is your a and your b is 3. And because b is greater than a, i.e. 3 is greater than 2, it's going to be a Limacon with the inner loop. Has this form here. If it was reversed, if this was a 3 and this was a 2, then it would be a Limacon without an inner loop. If the numbers were the same, then it would be a cardioid. So that's the difference between the three. All right, let's go ahead and graph this. Since we're going to use the fact that it's symmetric with respect to the x-axis or the polar axis and assign values for theta. Let's let that be between 0 and pi, and then use symmetry to graph the rest of the graph. So let's use theta, and we're going from 0 to pi. So we'll start with 0, pi divided by 6, pi divided by 3, pi divided by 2, 2 pi divided by 3, 5 pi divided by 6, and then pi. And then we want to find out what our r is. So we have r is 2 minus 3 cosine of theta. So let's find our r value. At 0, we're going to get negative 1 for r. At pi divided by 6, you're going to get 2 minus 3 square root of 3 divided by 2, which is approximately negative 0.6. At pi divided by 3, we're going to get 1/2. At pi divided by 2, we get 2. At 2 pi divided by 3, we get 7/2, which equals 3 1/2. At 5 pi divided by 6, you get 2 plus 3 square root of 3 divided by 2. That's approximately 4.6. And at pi, you get 5. All right, so let's plot these points and see what we can come up with. These are kind of hard to graph. So at 0, at my angle is 0, we're at -1. So that means instead of to the right, we're going to the left. So that's where we start there. I'm going to take this out so I don't get confused. All right, at pi divided by 6, we're at -0.6. So we're going this way, coming back in. All right, at pi divided by 3, we're at 1/2. 1/2 is about right here. At pi divided by 2, we're at 2. Right here. So let's see what we have so far. It's going like this. It's coming up to 2 like this. All right. And then at 2 pi divided by 3, we're at 3.5. So swinging up here. And at 5 pi divided by 6, we're almost at 5. 1, 2, 3, 4, 5. I'll just put it right about there. And at pi, we're at 5. So we have 1, 2, 3, 4, 5 right here. So this is half of the graph. So with symmetry, we know that it's symmetric to this axis here. So it can fold on that and it should match up. So let me try to match this up at 7 pi over 6. That's going to be about 4.6. So right about there. At this one, it's going to be, what was that? 3.5. 1, 2, 3.5. At 3 pi over 2, it's going to go to 2. 1, 2. So do you see it's going around this way? All right, what's going to happen here at 3? We get 1/2. So here we go here. And then at the 6, we have negative. So we're going to go back this way. So at 11 pi over 6, we're going back this way. Then it should connect. So there it is. So we started here. It goes around. And then it's looping through. It's going to make a little loop there. And that's it. Thank you. Have a nice day. Bye-bye.